Unit cost depreciation. Some items lose value because of how often they are used rather than because of their age. So for example, a photocopier that is 2 years old but has never been used could still be considered to be in brand new condition and therefore worth the same or close to it, what it was 2 years ago. They're not always going to be the same, but it'll be, if it's brand new, it hasn't been used a lot, then it's okay. But if the photocopier was 2 years old and had printed many thousands of papers over those 2 years, it would be worth much less than its original value. Makes sense because it's been used a lot. Cars can also depreciate according to their use rather than time. People often look at the number of kilometres a car has travelled before they consider buying it. An older car that has travelled a few kilometres overall could be considered a better buy than a new car that has travelled a larger distance. So, for example, we could buy a 62 Holden that's been in really good nick and hasn't done many kilometres. It could be worth hundreds of thousands of dollars. Whereas a brand new car, a Ferrari, say for example, well, it'll lose its value if it's done a lot of kilometres over a year's period. So it won't be worth what the older car would be. So there's just a tiny example. So when the future value of an item is based upon use rather than age, so use rather than age, we use a unit cost depreciation method. Unit cost depreciation can be modelled using linear decay recurrence relations, same formula. So this makes sense to you. Let V of n be the value of the asset after n units of use. Let D be the cost per unit of use. So the recurrence relation of the asset after n units of use is the initial value V of O here, and V of n plus 1 equals Vn minus D. So we're using the same as we used before, except that the depreciation, the D, we're not dividing it by 100, the interest rate, because we haven't got a set interest rate here because we're talking about use each time. So let's have a look at an example. A professional gardener purchased a lawnmower for $270. The mower depreciates in value by $3.50 each time it is used. Easy. So the initial value, V of O, was $270. Every time we use it, we lose $3.50. So you can put that into the graphics calculator, can't you? 270, enter, minus 350, enter, 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 1 use, 2 use, 3 uses, so on and so forth. And then you can get your recurrence relation from that using that method. The depreciated value of the lawnmower is modelled by this, which we've just done. Now it says use the model to determine the value of the mower after it has been used 3 times. You can do that. How many times can the mower be used before its depreciated value is less than $250? So if you dump that into the calculator like we had done before, 270 minus 3.5, enter, enter, enter. So that was initial V of O is there. 1 use, 2 uses, 3 uses, 4 uses, 5 uses, 6 uses. So now you know to answer the first part of the question, use the model to determine the value of the mower having used 3 times. 1, 2, 3. The value of the mower after being used 3 times is $259.50. That answers A. Sorry, go back up one. So then part B says, how many times can the mower be used before its depreciated value is less than 250? Less than 250 is here, right there. After how many mows? 1, 2, 3, 4, 5, 6. After 6 mows, the value is less than 250 at $249 is the value. Simple. Now you can work on exercise 8C, all questions.